What's up guys, this is LeetCode 7, reverse integer. Given a 32-bit signed integer, reverse the digits of an integer. Example 1, the input is 123 and the output is 321. Example 1, the output is just the input read from back to front, so 3 3 2 2 1 1. Example 2, we have to handle negative numbers. Example 3, we have to handle numbers that end with 0. Assume we are dealing with an environment which could only store integers within the 32-bit signed integer range, which is this range here. For the purpose of this problem, assume that your function returns 0 when the reversed integer overflows. Okay, so this is important information because we have to deal with this. There are some ways we can deal with this in C#. The first one is we can store the result in a variable bigger than 32-bit signed integer. We can use long for this, and every time we make a calculation, we can check if the result is bigger than or less than this range, is out of this range. The other way, we need to understand that C# compiler will not throw an exception when we are dealing with a 32-bit signed integer, and the range gets overflow. So the C# compiler will not throw an exception. It will just start the odometer again, and the number will start to get bigger after it gets smaller, and that's okay. It's just how the compiler works, and we can force the compiler to throw an exception. In this case, we just need to use the checked word, the checked special word here, and in this way the compiler will throw an exception in this case, and we could just handle the exception. So I think this is just a design decision, and yes, we can decide during the resolution of this problem. Let's get back to the example 1 and try to think how can we solve. The first thing that comes to mind is convert the number into a string, apply the reverse function, and convert again to a number, and that will solve this problem. But I'm not sure if that's the solution that this exercise is asking for. We can check here in the related topics, and yes, this should be solved using math. And we can do this. We can let's think. The first thing that we can do is to get the last digit of the number. How can we get the last digit of this number here? We can use modulus calculation. The modulus calculation is the reminder of the division. So as we are working with decimals here, if we calculate the modulus of this number by 10, the result would be 3. So that's the way we can get the last digit of this number. But we also need to remove this number, this digit here, from this number, and we can do that by using division. So if in one hand we use the modulus calculation to get the last digit, and on the other hand we use the division to remove this last digit, because 123 divided by 10 is 12. So that's the way we can remove this this last digit here. Okay, so we already know how to get the last digit, and we already know how to remove the last digit. Now we can start to think how to build this number here. So we have the last digit, we can put here, we can get the last digit again, and we can sum, but the sum of these two digits is 5. Okay, so we cannot sum directly, we have to do a multiplication before. Yes, so if we get 3, we save 3, and in the next iteration we multiply 3 by 10, which returns us 30, and then we sum 2, so we will get 32, and so on. We will get at the end the output expected. Yes, that's it. So let's see how can we code this. Okay, so let's start to write some code. So we can start by declaring our result variable, and as I said, we have a decision here, a design decision, and I decided to handle the overflow as an exception. So I will declare just an integer here, a 32-bit integer, and at the end of this function I will return it. Okay, that's the first thing we have to do. Next one, we need to calculate, yes, we will calculate x till x is greater than 0, and by now we have to handle the negative numbers because we will transform x in case it is negative to positive. So let's do this right now. So x first, let's see if it is negative. It is negative, it's equal to x less than 0. So if x is less than 0, it is negative. And also if x is negative, we should transform it in positive. So we can do this by multiplying x by -1, otherwise just get x. Okay, so we should also do this check here in the result. So if is negative, we should multiply result by -1. And also, on the other hand, if it is not negative, we just return result. Okay, so now we can start the calculations. So we will calculate x till x is greater than 0, and we can do that by just checking if x is greater than 0. Now we can start this by getting the last digit of the number. So the example 1 has 1, 2, 3. We want the digit 3, and we know how to get this. We can just get the modulus calculation of the number 3, right? So we can do that by, let me see, just do some addition by x modulus 10. So x modulus 10 will return us, in this example, the number 3. And we need to update x. We need to remove 3 from the x. So we already know how to do that. We can just divide by 10. And as I said before, we also need to do some calculation with the result before we do this addition here, which is the multiplication by 10. Okay, so if we don't have any typo, this should be the solution. Let's try to run the code. Okay, so let's try the negative sample because we are already handled this. Yeah, the only thing that we are not handled yet is the case where we get overflow. So we can do this, as I said, using the checked word here, and we will handle this as an exception. So now we are doing a calculation within a checked word, and we just need to care about the exception. So let's try cat this. Okay, so we will care about the overflow. I don't know, it's overflow like this, exception. Okay. As we are not doing anything with this exception, we are just handle it to return 0. I will not care about the exception, and for this exercise, this is the only exception that we will get, I think. So I don't know if this is also possible, so just put the brackets again. Okay, so now we are handling the overflow exception when our result in some of these calculations here get bigger than the 32-bit signed integer. So let's try if we did not introduce any typo. We didn't. So let's hit submit. That's it, guys. Thanks for watching.